Hello everybody for this analytical April session. So in today's session we'll be going through this exercise for the R track, which is about processing the data about a tournament. I hope the screen is visible properly. Okay, let me try to reshare it once. Okay, so we'll first walk through the exercise and then we'll switch on to the ID. So the exercise is in the R track. The exercise is called tournament, wherein given a file, a text file, which is about the matches being played between two teams. So as an illustration, this is a sample of a file where team 1 is Allegoric Alaskans versus Blithering Badgers, and the result is win for the first team. So whatever is the result at the end of it, that correspond to the first team. So that's how it means. As you can see here, the result of the match refers to the first team listed. So the win means the Allegoric Alaskans did win this match. Similarly, is courageous Californians suffered the loss, and that's why Blithering Badgers were the winners. And finally, if both are draw, then basically both are draw, right? So based on this, we this as an input, we have to come up with an output which looks something like this, where individual teams, so across these 6 lines, if you see, there are 4 different distinct teams, and that's why in the output we have 4 different rows. We have to couple of information at the end of the processing about each of the teams. The first one is number of matches played, the number of wins of that particular team, the number of draws for that team, the number of losses for that team, and finally the number of points earned by that team. So as you can see here, the points is simple enough to calculate. A win earns a team 3 points, draw is 1, and loss is obviously 0. And the eventual result has to be sorted by the total point which has been accumulated by the particular team. So this is how the final result should look like. Okay, so toggling back to the IDE, let's spin up a new so yeah, I'll be now sharing my RStudio IDE screen. For the sake of this demo, we have already created one file which is called dat.txt. If you see this one, this is the exact one which we saw there. So just copy pasted it so that in order to avoid wasting time to create the data from scratch, this is just a copy paste. Now for this one, I wanted to start with a simple enough code, and that too in base R, so we won't be using any library beyond the standard library, right? So it would be all base R. No tidyverse, no data table, although they can perhaps make things faster. We'll just go with base R for this one. So let's start with reading the data, and let's call that as dat or DTF, maybe data frame, right? So read.csv, and then the file is on my desktop, so this is in dat.txt. A separator, as you see here, it's a semicolon, so we'll going to otherwise a default would be a comma. And then header is false. I mean, one thing to remember here is there is no header by default, so we're going to create our own headers, right? Maybe just make this a little better. And my call names argument, my custom column name. So let's call this as team1, team2, and an outcome, right? So team1 is my first column, team2, and then the outcome. So this is how the data looks like. Let's quickly look at the data. All right, in terminal it is as we expected. Then we go to the code back. What you want to do is you have to tally those outcomes for each of the teams. So we have to, if we can define upfront the number of teams, that would be even better. So let's do that. So how do we find the unique teams, right? So the teams are both present in column 1 and columns 2. So we will combine and seize the combine operator. So DTF dollar team1 and DTF dollar team2. So this is how we're combining all of the team names from two, and then we take a unique of them, right? Unique, and this will tell us a unique name. So let's run this and see what happens. So yeah, we have these 4, right? And just for the sake of looking a bit nice, we'll sort them as well. And that will not change the number of unique teams. It will be again 4 teams, and let's call them as team names. Let's call this character vector as team names, right? So we have team names and unique number of teams. Let's say this is a team, and this would be length of this vector team names, right? So we have 4, as you can see here, 4L. We have 4 teams, and one thing also, because we want to process this data frame one after another, I mean line by line or each game by each game. So let's create a game ID as a new column in the data frame. So let's call this as DTF, and this is how you create. This is one of the way how do you create it. So create, and you maybe, yeah, so either you can use a $sign or you can use a double square brackets, and there is a double, within double quotes you can say game underscore ID. It's the same, and what do you want? We want this to be game 1, game 2, game 3, so on game 6. So this is nrow DTF, right? So now we have a game ID column as well. Let's go and see. It's there. Now what next? So if we recall that we wanted to create couple of columns, right? So let's revisit that quickly. I'll still toggle my screen back to the browser. So now we just go back quickly to the Exercism sheet and see what do we want, right? So we want these. Let's copy them for the timing. So match placed, W, D, L, and P. These are a couple of statistics which we are interested in about each of the teams. So we'll just, for the sake of reference, we will copy them and paste that back into our IDE. So just for the reference, I mean this doesn't mean anything here, so I'll just comment them out for the time being, right? And these are the stats, maybe, yeah. So what do we do, right? We have to define a placeholder, right, for each of the statistics across all the four teams. So there are like more maybe concise way to do about it, but let's be explicit here for the sake of just detailing out the solution. So we create 5 lists corresponding to this 5 statistics. So list MP is my list of match points or match plates, sorry. And what do we do here? These are, since all of them would be integers, right? Number of match played, won, drawn, lost, and points. Each of these are integers, so we are just going to define a vector of integer, and where mode is integer and length is equal to n team, right? And let's make them a named list, and we'll come to why we're making it a named list. So names of list mp would be list team names, right? And let's do this 5 times. So this is already 1, 2, 3, 4, 5. Obviously we want second to be 1, list of matches 1, and then list of matches drawn, and then list of matches lost, and list of match points, basically total points 1, right? So this is that, right? So see here, so far DTF and team names. Now we'll be creating these lists too, and the placeholder would be 0. I mean, whenever we create a vector, it automatically initializes the values as 0. So we'll see that in a moment. So yeah, just run all of it, right, and see. Just sanity check. 4 values, all zeros. 1, all zeros. All zeros. Losses, all zeros, and then points, all zeros, right? So we're done with initializing, and we'll combine them together at the end to create a data frame which we want as an output, right? So you can see here, now we have match points, match played, match won, match drawn, match lost, and total points. It's 1, 2, 3, 4, 5. Now on to the actual logic of how do we go about doing that from the raw data which we see here, right, in DDF. How do we go from there to there? So what do we want to do is we will be iterating over the match IDs, the game IDs, and we'll process. I mean, basically, let's processing game info. It's a good idea to keep uh, pasting short snippets in English to jot down our thoughts of what we are going to do. And since we're processing a couple of games, it's also a good idea to just show on the terminal what we are doing. So we want to keep track of where we are. So processing game, and percentage %d would mean uh, a number we are referring to, a number of the game ID. So that is that. So when we run this loop, we'll see that we are processing each ID, right? And now let's process it, right? So first of all, whenever we encounter a particular game, for that particular 2 teams, the match played counts increases, right? So let's do that, right? So now here we'll quickly mention why the named list is important. So for example, let me create a very quickly temporary vector of maybe length 2, right? So this is temp, right? And names of temp be A and B, right? So now this is A and B. Now if I want to refer to an element of the vector temp by a name, I can just simply do B, and I can update its value or retrieve its value either way. Maybe let it be 100, right? So now what do temp is, temp becomes 0, 100, right? So that's the concept we are going to use here as well. So I want DTF $team1 for the ith game, and its value to be incremented by 1, right? So that's what we are going to do here, plus 1, and similarly for the second team 2 as well. So this is 2, this is team 2, right? So for team 1, for the ith game, we increment it by 1, similarly for team 2. So this is for matches played, right? Now on to here the stats about won, drawn, lost, and points, right? So if EDF dollar outcome of the particular game ID is equal to draw, right? Um, so in that case we will increment the point by 1, right? And there is no losses, no wins, so they remain as is. So let's uh, so what will okay, sorry, list of draws and of whom TTF dollar team 1 of the ith game. So number of draws, basically we are updating the statistics of number of draws for team 1 by 1, and similarly for team 2 by 1 as well, because both the teams have just had a draw, right? No effect on losses or winners. Okay, so this has already been accounted for. No wins, loan loss, and the points. So this is about the loss, the draws, right? Draw count basically. What about points? We also want to tally the points too. So point count, and it will be basically exactly the same, right? Because everybody gets 1 point if there is a draw. So list of points, list of points, list of points here, and list of points here. So basically when there is a draw, everybody have unavenged draw, and that's why everybody got 1 point, and that's why we have updated the list P, which is points, tracking points, by 1 each, and the number of draws by 1 each as well. Now for if you're, maybe just copy it as well, in case of win, right, what happens, let's try to see. So in case of win, there would be a winner, there would be a loser as well. So win count, who won, the team won in the order is the winner if their outcome is 1. So for them, the list of W, which tracks the number of wins for team 1, right, because 1 in this case would be the winner, is incremented by 1. The second team would be the loser, so loss count, right, in this case L, and the team 2 has lost it, so L and team 2, right, and then finally the point count, and in this case the second team hasn't won anything, so we'll just update for team 1, and that is 3. And finally, I mean, this will be just the other way around for a loss. So if it's a loss, the win is for the team 2, because the second team in the order, as mentioned in the question, is the winner, right? So in this case, for example, if you see the last one, Courageous Californian versus Blithering Badgers, the outcome is loss. The loss is for Courageous Californians, and Blithering Badgers is the winner, right? So team 2 is the winner in this case, and that's why for the loss, team 2 is the winner, and we are incrementing the win count by 1. The loss count of team 1 would be incremented by 1, and the point count for team 2 will be increased by 3, right? So 1 2 3, so we are updating wins, losses, points, draws, and match played, all 5 of them, right? So yeah, just let's run this, I think, and see where we are. Yeah, okay, so let's see what are the values here. Everybody has split 3, okay. The wins are looking some values. We'll check the expected outcome once we come up with the data frame as an expected output. So let's look at that once. So this is the this is basically, we have updated all the 5 um, metrics or statistics which you want to capture for each of the teams, right? Now on to creating a data frame out of it, right? So let's call that result DTF, right? And that would be data.frame. uh, right? And the first, let's quickly jump to the the other tab where we were discussing the problem statement, and let's try to see the kind of output, the format of the output they're seeking for, right? So we'll just quickly jump there. I'll okay, so I will share my screen again and go to that window. Okay. So this is what we're after. So let's copy this, right? Maybe this is our expected output too. So this will help it in two ways. Firstly, to determine the format, and another way is to to see the expected outcome, right? So I'll go again and share my ID of the ID. Okay, and here we are. So let's see the expected results. I'll just copy it here. The result. Again, this is what it is, right? So the first column is team. So let's say this is team, and what would this be? Team names, right? Basically. And the second one would be MP, and that would be list MP, which is matches played. Third is W, and this is list of W. Then we have draws, number of draws, and that would be list of draws. And losses, and list of number of losses. Finally, number of points won, right? That's the most important, I guess. And we have a list of P, right? And if somebody, I mean, among the viewers who are working in R 3.6.x or R less than version 4, so you may have to, I mean, although this doesn't affect our problem, but on the safer side, you want to keep your strings as strings, not as factors, for R less than 4.0, because in R 4.x and greater, while creating a data frame, your character vectors are not converted to factor by default, just to be on the same side for people who are using older versions of R. So here we have our value, right? And this is what it is, right? So let's see. So we do see that these three tally here, and you have devastating donkeys is 7, which is here, followed by allegoric Alaskans, which is 6, again correct, followed by blithering badgers 3, and courageous Californians is 1. So this numbers tally a bit, right? But probably they are not in order of what we're expecting, right? So one last thing which is remaining to be done is to basically order this, right? Order the result DTF in a manner which is expected. So how do we do an order in base R is we use the order method, and if you are doing okay, and by the column, this column by default is ascending, so we have to use a minus sign here, so that will sort the result in descending order for the column P, and we are restoring that as a result DF, right? Test result DF, and let's see what the outcome is finally, right? So this is the final outcome here, 3 3 3 3. I mean, so column by column. So we have the team as okay. It seems that there is the column names, the row names has also been there, so I'll delete that to make it more cleaner. Okay, while creating a data frame, think row dot names is equal to null. Okay, so let's do that, and then rerun the sorting again. So let's see what do we have, right? We have devastating twin trees, allegoric Alaskans, blithering badgers, courageous Californians. 3333 is MP. Win is 2 2. As here, draw is 1001 1001 122 122, and finally the points are 7631, right? So I think yeah, here we have it, our solution to the problem of given a file like this, a 3-column file with 2 teams and the corresponding outcome, possibly 3 outcomes of win, draws and losses. How do we output something like this? Of the kind of problems you see when you're starting out in data analysis, you are given a data, the format could be different. I mean, here we see the separators are semicolons, which are somehow uncommon, and usually it's semicolon most of the time. Oh, sorry, comma most of the time, but here it's semicolon, so it's a little bit different, odd probably. Yeah, so and that's where the read.csv allows you to specify your own separators, right? And yeah, and then you are eventually required to manipulate the data or angle the data and present in an order which makes sense with the stakeholders, right? And then some decisions will be taken on top of it. So this is usually the very first things people do when they start out, right? One maybe we have some more time, so we'll try to see if that can be done. So one cool thing which can be done is, rather than doing this all the time again and again, why not create an app, right? A very basic app which sort of takes your input as a, I mean, you can upload that, right? And then basically you uh, just then as soon as somebody uploads it, see the results right away, right? Just upload and run. And they may not have R at the local machine, so they may, they didn't know R how to code, so the stakeholders or business stakeholders who are not very well versed with programming, this kind of analysis could be made interactive, where you host your app or your Shiny app in this case, to be more specific, and you just upload the data in a specific format which is required. Of course, you have to do some kind of data validation and appropriate alerts, which we are not covering here, uh, but yeah, I mean, they'll see the results right away, right? And it sort of takes away some sort of friction of how do you share with them tool to accelerate decision making, right? So let's take a shot at it. Let's see if we can do it in the time remaining, all right? Okay. Okay, so we'll start with the boilerplate shiny file. Let's I mean, RStudio allows you to do that. So what do you want to do? We want to create a shiny web app. We want to probably do it on desktop, and then open. And what do we want to call the application? I mean, application name as, let's create a directory perhaps, right? And create test app. Okay, and what do you call that application name? Probably tourney create, right? We have created two boilerplate codes here, right, for UI server. Will it come to a moment, please? And okay, coming back to the UI part. Uh, so let's just quickly change the, I mean, so basically you need the Shiny package, and Shiny package allows you to structure, I mean, the UI part consists of all the elements you will be showing on the browser, whereas the server will contain all the logic for the app, right? So here title panel is a function which allows you to display your title, application title on your browser tab. So let's call tournament, right? And the sidebar layout is basically, I mean, let's run it basically, right? So let's run it and see what comes out of it by default of the vanilla Shiny app which was created for us. App here is this test, right? And launch browser is to true. Let's see what do we get. What do we have here? Where it, okay, inside Tony. Sorry. What do we get, right? This is a simple app about plotting histogram dynamically, right? This is what you get, right? So this is a sidebar. This is the main panel, right? So basically all the input widgets you can place it in one side of the screen, and the output shows gets shown on the right hand side of the screen. I mean, there is a lot of flexibility in case how do you want to modify your look and feel, but we are not going to go into that for this stream. Let's toggle with it. What do we want? We want something called as a file input, right? So file input, and let's, so how do we specify a file input, right? Start maybe with a CSV file, or choose a file, in this case a colon separate file. So but let it be a CSV file, I mean, doesn't matter, uh, except text CSV, that, right? That's what we want. And maybe we don't want really to I mean, let's keep it simple, and let's not add an action button. Although what we can do is, once you upload a file, you wait for a button to be clicked and you show an action button where people click on the button and then only processing happen. We are not doing that. So file input ID is file1, which will see what's the use of input ID. Soon enough, choose a file is as a label which is shown on top of the widget, and we are only asking for one file to be uploaded at once, right? And text CSV basically, right? Let's make text part. So this one is, and our sidebar panel has closed and made panel, right? So Shiny output, right? And this is the table plot. This is where our table would be shown, right? So this is about the UI part of it. Very simple. Only accept a file and then just plots a table, right? Show a table of result. And let's go to our server, quickly jump to our server. We will, whatever is the output ID of our output widget here. Same goes by convention in the output dollar. Yeah, right. And we are doing a render table, basically shiny render table, right? So this is a one-to-one correspondence. What you say is wherever it's output, we right, right. So render corresponds to the output, right? That's what the convention of shiny says, right? And we'll do some processing and show the table here, right? Okay, so and this is exactly the same processing which we saw earlier too, right? So what do we need to do here? Basically, let's just copy what we have done. I mean, basically, this is what we'll be doing exactly. So no change. We'll be deleting those relevant portions, perhaps, and these two, and rest would be needed there, right? So let's just copy the entire thing in our code block under trend table, right? And yeah, and we say return result TTF. So let's see what's happening here, right? So we have a file which is file one, right? And file one, I mean, it's not I mean, as you have seen here, we are passing exactly the path here. When you upload a file via shiny, it gets stored in a temporary directory in /temp or in your Linux machines in a chosen location by the OS at that point of time. So here, in that case, we'll be providing that location as something like this. So input means it's coming from the input widget, which was there in the UI. File one is the handler, and data path points to the location where the is there, right? Temp, wherever it's the temp, is an randomly generated location every time, so it gets changed, right? And basically after that everything remains as is, right? No changes at all in the way the logic works, right? So you see, I mean, the logic remains as it is, right? So let's see what happens, right? I mean, it's as simple as that. You have a layout. Just to recap, there's a sidebar panel, there is a main panel. You can change the width of the sidebar panel and make it narrower or wider. Similarly for main panel, I mean, as you can see here, there are options of it, so you can play with that. But default you have 8 and 4. I mean, since shiny is based on top of bootstrap CSS framework, it divides the screen vertically into 12 columns, and that's why by default you see in main panel you have width as 8, I guess, right? Or 2 by 3. So that's about it, right? And you input something from the input widgets, which is file input here, that gets reflected here in input dollar, the same ID which you are using here as file one, and then yeah, everything remains as it is, as it was earlier, right? And we return the table here, and the rendered table then hopefully will show the results at table output. So let's see what happens. Let's give it a go, right? And you can also specify your port too. So I'm just using port 8000. I mean, it's optional. By default shiny chooses any random port in a certain range. Let's do that. So okay, let's see. So this is not, I mean, this is an error. I mean, this is because there is no requirement check which has been done. So we'll if time permits, we'll see how to take care of that, but not a problem right now. Let's do that dot text, right? We do and see right away the results is here, right? It's we, I mean, just to be sure that we are not, like, this is not pre-done, right? So let's edit the txt. I'm not sure. I think this the app is visible right now, so I will be sharing the screen, the full screen now, and hopefully you can see the toggling happening right between the two windows. Okay, so I do a run app. It takes us to a browser window where we see there is an error, but since because we have not done a logic check which says that a file has to pre-exist, so we'll take care of that in a bit. But if we go and choose a file, right, which is that, we will see the results right away, right? So just to make sure that if we change our file, right, this file, maybe just add one bit here to the end, and what it says is now the number of matches plays for allegoric Alaskans and blithering badgers would be 4 each, right? And for allegoric Alaskans, I think here the win count is true, so it will become 3, and thus their point 1 would be 9 in that case, right? And from blithering badgers, the wins will be 2, so they'll be at 6, right? And their, yeah, so no, so they are again the loser, so their losses will become 3, right? So this would be 3, this would be 3 again, and this would be 9, and that's why this one should go at the top, the allegoric Alaskan. So let's see if that happens, right? So we will maybe choose the same file again, dat.txt, and see, right? So number of matches played for allegoric Alaskans is 4, blithering badgers is 4. They have 3 wins now with total points 9. Blithering badgers have 3 losses, they still at 3, and devastating donkeys come at 7, right? So this is how you simply create something which is supposed to be used multiple by your stakeholders and make that into a small shiny app which allows them to just uh, I mean, and right on a server, for example. uh, I mean, one doesn't need to have R installed on their machine. I mean, they just simply hit the URL wherever it's pointing to, the app it's pointing to. They just choose browse, upload the data, and boom, the result is there. So I hope that that has been useful, as and this has shown you how to build basic shiny apps, and possibly how do you approach a problem, a basic problem in R of about data wrangling or so, right? I think one thing we didn't touch upon was there was this error which was coming in, so let's also probably tackle that too. And when we were launching the app, it says that there was an issue because there was no file which was present already. So REQ allows you to say that just check for if the file is already present somewhere in your machine. If it's not, you don't even process it, right? Because if you don't do this, this line will assume the file exists and try to read it. Obviously it doesn't exist, so it throws an error, right? In this case, now even if we have not uploaded a file, we are app from fresh, we will see that now that red error goes away, and then once we just do dat.txt, we see our result, right? So that was the making about data validation. So I think with that we have come to an end of our session. I hope you have liked this, and yeah, we'll hope to do the same sometime soon again in April. Thanks.